And I have a question. So do you have to put only 1, 2, 3 in there? Oh, actually, you can put any numbers you want. So this student is asking about the random numbers, which is on the chapter 5. So let me go to the contents of the data camp. So this week, you learned the various things. So the first chapter was matplotlib, which is a primary tool to make a graph. And the second topic is a dictionary, and you are also introduced to pandas, which is the third important packages. The most important one is the NumPy, and you are going to use the matplotlib. And then the third one is pandas. So we almost always use these three packages. And then the next two chapters are this logic, control flow, filtering, and loops are the most fundamental concepts in programming for any programming languages. And it's not so bad because it really looks like the common English sentence. So for something in some range, you can do the things repetitively, and that's the loops. And the logic is, if this is true, then do the following, that kind of things. And then final one is the some sort of a small project to use all the techniques you learned here. So the question is, in the hacker statistics, it introduced the random numbers, and then the random numbers means, yeah, it should be random, but mathematically we cannot make the whole random numbers because then the computer cannot do that, because for computers, there should be a formula always. So we use the so-called pseudo-random number instead of the real random number. And he explained how to set the first the seed, and that seed is maybe some starting numbers, which is not the starting numbers, but it's a seed. So the students asking about, so do we have to use only 1 to 3? No, you can use any numbers you want. So for example, I'm going to show you an example. Here it's a collab. So usually we start from import NumPy as NP. And then this NP has a random number generators. So one of the good thing in Colab is, if you press the dot and wait for a second, then it will shows you all possible valid commands. So you can make binomial random numbers, or some other things. I think it was a rand int. So np.random.rand int, and then when I press random int takes one position. Okay, so maybe 1. Then I got 0, but if I have 10, oh, so the rand int is, it gives you an integer between from 0 up to not including 10, I guess. So if I said 1,000, then I can get 959, and if I run it again, then I get the different numbers. And every time I do that things, I get the different numbers. And if you are trying to do the same thing, you will get different numbers. So in order to have a reproducibility, they start with NP random dot seed. So if I set it as so in the exercise it's 1, 2, 3, but I can do 1, 2, 3, 4. Then every time I started with the 1, 2, 3, 4, I can get the same result, and you also get the same result as mine. So this is the way we set the random seed, and that's a very good question. Yeah. So that's because you are just in the beginning of the learning process. Yeah, sometimes you should put something in the parentheses, and sometimes you left it as blank. So let me do the PLT thing. So I'm going to import the matplotlib. So it's import matplot. And you can see, I did not type anything, but your screen shows me some suggestions. And I think the first one is what I want. So matplotlib.pyplot as PLT. And it imports the matplotlib packages. And I'm going to call it as PLT. So let's practice some. So it's plt.show. And nothing shows up because there is nothing to show because I did not make anything. So maybe I can say plt.plot is the first thing. And then some object dot the method. So some method needs to have the arguments, and some method does not need an argument. So for example, the plt.show does not need any arguments, but plt.plot needs some arguments. So if I execute this code without referring to anything, then it's some graph, but there is nothing inside. And when you press that your cursor inside that, usually they show some hint. Okay, it's PLT. Okay, then you can see some arguments here. So I'm not going to move my mouse, but you can see it takes some arguments and it shows you some examples. So for example, PLT X, Y, and some forms. And do you have to memorize all of this? I cannot memorize all of them. So I just remember the minimum part. And then if I need it, I'm going to the Google and to search for something. So maybe the minimum thing is the Y. So maybe you can put some numbers, 1, 2, 3, 3, 10. So I think that is the minimum of the to show something. And actually it shows some part, but it is recommended to use the plt.show at the end. So I did not okay, so you can see the difference between these two. plt.plot 1, 2, 3, 3, 10 gives you a plot. Also, it gives you some message here. So if I wanted to get the plot only, then I have to write plot.show and open and close parentheses. Then it just shows me the plots. And sometimes it is very useful. Not sometimes, and actually you have to use the plt.show at the end of your plot, because sometimes you wanted to make several plots on the same graph. And in that case, the PLT show do the things for you. Oh, okay, yeah, and the hist is a histogram. So I think, yeah, that's enough. So when you have to make your parentheses empty and when you have to put something inside, that depends on what are you gonna do. Oh, sure, yeah. I can show you our Learn Us page. And I already graded your first assignment. So it's week 2. The first assignment was Introduction to Python. And we have 138 students, and 136 students submitted the assignments. And there is nothing that I need to grade because I already finished all the gradings. And you can find your score maybe around here, grades or grade rate. Probably your screen is different from mine, but you will check whether you got 0 or 1. Most of you got 1. Okay, when you are going to initialize the random walk. Yeah, this one is actually means, yeah, you're gonna start from the 0. So let me make a variable random walk. And maybe I can start from just, empty string. And you'll see, what's gonna happen. And then I'm going to make some random numbers for I in range 10. For I in range 10. And then for the for loop or the if statement, you have to put the colon at the end. That's absolutely necessary. And then it will automatically indent your program. And I can say, random walk dot append mp random dot rand int, say 100. Then every time it is executed, it will generate a random number between 0, random integer between 0 and 99. And then it will append to the end of this random walk list. So after that, I can see what's inside my random walk. So let me do it. And the random walk is this. So usually the random walk, by definition, random walk starts from 0 and then going up or going down, do something like that. So random walk 0 means you specify your initial points. So that's the meaning of random walk is 0. Oh, sure, yeah. So in order to explain this, I'm going to explain it again, what it means A is equal to 1. So now you all understand what A is equal to 1. In mathematics, A is equal to 1 means the right-hand side and the left-hand side are exactly the 1. But in programming, it's not. You you should not interpret it, this statement in that way. So the better way to understand is that, okay, whenever you see the equal sign, it's not the equal sign. It's an assignment statement. So on your right-hand side of your the equality sign, evaluate on the right-hand side and put it on the left-hand side variable. So that's the meaning of this one. So it is possible that A is A plus 1. So in mathematics, it does not make sense because any number cannot be the same as the original 1 plus 1. But in Python, yeah, it makes sense because I assigned A on number 1. So on the right-hand side, A is 1. And then we evaluate the number on the right-hand side. So A was 1 and plus 1 is 2. So when we evaluate on the right-hand side, it's number 2. And then that number 2 will be assigned to the left-hand side variable. So once this statement is executed, the A is now number 2, not 1 anymore. So A is 2. And there are lots of statements like that. So the computer programmers wanted to make it short. So this is another way to write the same thing. You see, this is strange. A plus equal 1. But this is exactly the same meaning as this one. So since I execute this part, what would be in the A? It's 3 because A was 2, but because of this statement, the 1 is added to the original A, and then it becomes to the 3, and 3 is assigned to the left-hand side. So this is a shorthand notation. So now you can understand these shorthand notations. And actually, this is the only shorthand notation for this one, but the people think that, well, if plus is possible, then why don't we have the minus is possible? So it's minus A, but actually I'm going to make it a comment because I'm going to make it a comment. This is exactly the same as A is A minus 1. And for another example, it's A times equal 1 is A is equal to A times 1. And also it is possible to write A slash equal 1 is A is equal to A slash 1 or 1. So do you have to use the 1 only? But it's not. So you can use something like A plus 10. And that means A is equal to A plus 10. So that is just the shorthand notations. But I don't want the shorthand notations. I don't like that because just write some more. Some more, type some more, then everybody is going to be happy to read it and understand it. So this is x minus equal. So minus equal means actually, okay, I'm gonna write it in my way. Then it is equal to, it is equivalent to x is, I don't know how many x's are here, so I'm gonna copy, Ctrl V, and minus y by y. So these two are equivalent. So this is, yeah, very funny questions. And the double quotation and single quotations. Yes, yeah. At first, yeah, that's very confusing. And I'm going to erase this part because this is not a statement. So when we want something is a string, I also use the mixed type. Yeah. So sometimes I said it's A, B, C, D, something. So it's A, B, C, D. But as you can see, the result has just one, the single quotation marks. So then, A, B, C, D, and this is the same thing. So basically, these two are absolutely the same. So that's the way the Python define a string. Then why do we have two different ways to express the string? That's very simple, because for example, I am a student. Okay, I am a student, and you can see there is an apostrophe between I and M. So if only the single quote is possible, then I have to write in this way. So there is one single quote that I wanted to express, and inside that single quote, there is a sentence, I'm a student, but it has an apostrophe inside. So when I execute this part, it says it's wrong, because the computer says the first pair is a string, and then you put something wrong on the after the string. So this is an invalid sentence, invalid syntax. So how can we overcome this? In this case, you have to replace your outside quote into a double quote. Then it's I'm a student. But it's when I see the result, it's confusing, But as a human, we know what it means. And sometimes we wanted to have a double quote inside a string. So maybe this is what I wanted to say. So he said, I love you. And this is the sentence that I wanted to express. But as you can see, it has already quotation marks. Then how can I let the computer knows that this is the whole thing is a sentence? Then you can make a single quote around it. Then it's a string, and I said, I love you, with the quotation mark. So the Korea with the double quotation, Korea with single quotation are the same thing. So how can you know that these two are same? And we can compare, say, Korea. And this is the common mistakes that you are first to learn the computer. So do you think this is correct? And this is actually incorrect, because as I said, the equal sign does not mean they are equal to each other. Equal sign means you evaluate on the right-hand side and put it into the left-hand side. And this left-hand side is just a string. So you cannot take even though it is the same thing, it cannot take the right-hand side to its string value. So when I execute this part, it's wrong. Then the question is, how can I compare the equality of these two strings? Is actually use it twice. So use it twice, and that really means whether it is equal to each other. So is it true or false? And it is true. So with double quotations or single quotations, they are the same thing. So yeah, it's a good question. Okay, transpose. So that's why you need to learn mathematics. Actually, the transpose is a linear algebra terminologies. So I'm going to show you the example of a transpose. So, yeah, there in mathematics, and you are a QRM or freshman students, you know that you are going to learn the linear algebra things. And the linear algebra is basically all about the matrix. The matrix is, yeah, something like in a big bracket, and it has 1, 2, 3, and 4, something like this. So let's say this is A. And sometimes we have to transpose the matrix, and that matrix is denoted by T on the superscript. And this is the notation for the linear algebra. And then what is the transpose? Transpose just means change the row and column of your elements. So for example, so we always set the row first and then column. So it's row 1, column 1. It's row 1, column 2. It's row 2, column 1. It's row 2, column 2. So when I write in this way, I write the row first, and then I write another row. But if you think that you want to switch the location of the rows and columns, then it's 1 and 1. So the first one is fine. And it was 1 and 2. But since I wanted to transpose, it's 2 and 1. So 2 and 1 is here. And it's 2 and 1. And if I transpose it, it's 1 and 2. So 1 and 2 is here. And it's 2 and 2. And when you switch it, it is still at the same location. So this is the transposed matrix. At first, it looks very confusing, but with a little practice, it's not that bad. So there is a matrix, and you can think about, this is the first row, this is the second row, and third row. And it's, of course, inside the row, there are lots of elements. So transpose means you're going to change it to a column, and then in that order. So first one first, second, third, and fourth. And then you're going to make this one as this one, and make this one as this one. So that's the meaning of the transpose. So let's practice the MP transpose here. So in order to do that, I'm going to make some matrix. So let's say it's MP array, and it's an array of, say, 1, 2, 3. And M dot transpose is what? It's the same thing, because in NumPy, it's so okay. Now I can understand why you are confused with the transpose. The better example is maybe I can make it a list of lists. So it's 1, 2, 3 is in a first row, and in another row it's 4, 5, and 6. So let's see what's inside the M. So it looks like this. So 1, 2, 3, and 4, 5, 6. And when I transpose it, it's 1, 4. Yeah. So yeah, you may think, yeah, it's 1, 2, 3, and 4, 5, and 6. But the NumPy always treat the so it always, yeah, think about in this way. So the M here is a big array, and the NumPy think that, okay, I have 2 elements inside that array. And then inside each element, there are another 3 elements. So in that way, the shape of this M is 2 by 3. Yeah, because there are 2 elements, and then inside each element, there are 3 components. So when you transpose it, then always the shape has been changed by here 2 by 3, but if you transpose it 2 by 3, it will become 3 by 2. So when you transpose it, and it will be this one, when you see the shape, it's 3 by 2. So yeah. Then why it is 3 by 2? How can I make this one as 3 by 2? First, M transpose should have 3 elements. So even though I write it in this way, it is 3 elements, and it should have 2 components inside. And in our example, it was 1, 2, 3. Actually, yeah, I can write in this 1, 2, 3, 4, 5, 4, 5, and 6. I always have a problem. So this is the original one, and you wanna change the row and columns. So maybe we can take this one as 1, take these 2 as the another one, take these 2 as another one. So it's 1, 4, 2, 5, and 3, 6. So that's the meaning of the transpose. Yeah, nice. Yeah, good question. Okay, is widely used is oh yeah, this is really confusing. Okay, the first one, the round parenthesis is widely used, but I would say that the round parenthesis is for the function. That is for the function, yeah. So let me summarize it in this way. So there are 3 different parentheses. The first one is this one, and it is a bracket, and there is a curly bracket. So main purpose of this one is a function, which include method. You see the method, the string that upper, string that lower, that kind of thing is called a method. And in order to use the method, you always, in order to use the method or a function, you have to use the round parenthesis. And this bracket is mainly for list, but it is always used for indexing and slicing. And the curly bracket is basically for the dictionary. And you have not learned the one more usage of the round parenthesis. It is for the tuple. And the curly bracket is also used for set. But you have not learned this part yet. So I think, yeah, these distinctions are enough for now to have to distinguish between the different use. So yeah, let's do some practice. So when we use the parenthesis, okay, yeah, okay, there's one more thing. This is also for the mathematical expressions, as we all know of. So, I mean, if you wanna add 2 plus 3, and then times 5 times 4, then you know that the parenthesis takes the arithmetic first, and then the result will be applied to this one. And in the real mathematics, we sometimes write the much bigger parentheses to denote them. Yeah, they are included in that to be included in that expressions, but the Python does not accept that. So if you wanna express that this one is you should calculate this one first, then you have to use another round parenthesis and then divide it by 5, something like that. And if you want to include another one, then use another parenthesis. So you see, it's getting more complicated, but yeah. So the first usage is for the mathematical expressions, and mathematical expression only accepts that round parenthesis. And then second usage is something like this. Yeah, hello, print hello world. Print hello. In this case, yeah, you need a round parenthesis. And it's, yes, true for plt.show as we did before, because plt.show is a method. So you need a round parenthesis. The second one is a bracket, and bracket is basically for a list. So if I want to make let's say B, and it's 1, 2, 3, and 4, then it's B. And you may ask, yeah, or what if I use just the ordinary parenthesis? And strangely enough, this is also possible, but this is the another topic. So this is called a tuple, which is similar to list, but have very different usage. So here, the round parenthesis does not mean any mathematical expressions, and it does not include it in the function or method. It is just another way to represent another data type called a tuple. So let's go back to the B. And you know that in order to index, so that means in order to select some specific element from a list, we use indexing. And Python index starts from 0. So how can we use the indexing? It's bracket. So B0 is 1. Then you may wonder, why can I use in this way the round parentheses? That means this B should be a function or a method, because the round parentheses means that you can use it here with a function or a method or in mathematical expressions. So if you wanted to execute this part, then it says list object is not callable. And callable means it cannot be called. And what can we call is a function. We can call a function, but the B is not a function, so it is not callable. So that is the second. So that is the for the B, you have to use the bracket to select some specific element, or you can use the slicing. So from where to somewhere, the slicing also takes the brackets. And curly bracket is mainly for dictionaries. Not mainly. Yeah, it is almost always used the dictionaries. And dictionary should take two parts, the key and value. So it's key 1, colon, and some value, comma. So this is the first element of the dictionary. And the key 2, colon, and some other, string. So it has, two elements inside. And D, so if you want to see the type of D, it's a dict. That means it's a dictionary. And I can access the elements of the dictionary with brackets. So this bracket is always used for used for indexing. So what's the value of K1? And it says K1's value is 1 to 3, because I said this is 1 to 3. So you cannot use in this way, because because let's see what's wrong with that. So dict object is not callable. So that means D is not a function. And even if you say that this is K1, we know that double quote or single quote are the same thing. It is not callable. So you should not use, you cannot use the round parentheses. So I think, I think, all those questions are really valuable, and it will really help you and other students, because you are just learning, you're just beginning to learn something new. And it's okay to ask me this kind of questions, so that I can show some possibilities and what is not possible. And at first you may not understand all of that, but as you listen every week, you will understand, oh, okay. And then finally you are very comfortable with all those things. I'm not sure what this is. So, oh, okay, MPRA is something. So we already know a list. So list is, this is the simplest way, but list is literally a list. It does not have any mathematical expressions. So what I mean by that is, you can say you can say 1, 2, and you can also include string as a part of a list, and then you can also add the true. And this is a list. And then the list cannot we cannot use the list for mathematical expressions. So what I mean by that is it's 1, 2, 3, and plus, let's say, another 1, 2, 3. Then what we usually expect from this kind of mathematical expressions is, well, maybe I can have 2, 4, and 6, but the result is this one. So it is just make it a bigger list. So that's the limitation of a list. So, but there are lots of things we wanted to do, some sort of the mathematical things for list. Then the NumPy comes up. So that's NP array, and I'm going to write the same thing. So NP array is actually it's a method. Yeah, np.array is a method. So we use the round parenthesis. So that makes I'm going to make something inside that to be to make it an NP array, and the NumPy type array. So that's the meaning of this function. So what's inside is a list. So it's 1, 2, 3. Then it returns an array. You may think that, oh, this is same as this one, but actually these two are different. The upper one is a list, and the lower one is an NumPy array. And what can we do with the NumPy array is that we can add, subtract, all that kind of things. So maybe I can copy and plus the same thing. So in this statement, I was trying to concatenate. This statement, try to concatenate two lists. But in this statement, it's adding numbers inside these two. So since it should be work on the mathematics, you cannot make an NP array something like this. It's a 1, 2, and a string. It's not a valid NumPy. Oh, it can. Oh, yeah. You can make a NumPy array in this way, but the problem here is that you see the data type of this one is something different from what I expect, because I said 1, 2, and string, and then the array returns string 1, string 2, and string strg. So usually the NumPy array, we have to have the numbers. But if you really wanted to have a string of an array, then that's fine. But in that case, every number is also converted to a string. So that's why we use NumPy array so many times, because we always wanted to do something with numbers. Is there a way when to use PLT CLF function during the programming process? Okay. Actually, I don't know yet what is the CLF. Okay, let me try. PLT CLF. Is the clear the current figure? Oh, okay. So usually we don't need this kind of things here, because we are using a interactive way to make a plot. So PLT plot. So it's a PLT plot. I don't think any nice example when we have to use the PLT clear figures, but sometimes I need that, because if you want to draw a graph first and then you wanted to erase it and then show the different graph in exactly the same location, then you might use the PLT CLF. So this is a very good question, but I cannot answer. Why I cannot answer? Because I don't use this kind of functions. I usually use, if I have to make a plot, then I'm gonna make several different plots. So that's why I cannot remember these functions. So that's a very good question to make me embarrassed. Oh, okay. It's or works. So I made a plot here, but okay, let me show you. Okay, this is the real example you can experiment. So we all know that MP random rand int 2. So it's a low high. Okay, it's a low high. Okay, low high. Then I could get 0, or I could get I have to use it 2. Okay, so the low is included, but high is not included. Okay, so maybe I'm gonna just make a walk is an empty array. Walk is an empty array. And then for I in range 100 and colon, I'm going to make a number. A is MP random dot rand int 2. So that means every time I'm going to make a random variable and then put it in a variable A. And then walk dot append A. Okay. Then I'm going to make a plot of PLT of walk and PLT show. PLT dot plot and PLT dot show. So this is the result of 0, 1, 0, 1, 0, 1. And if I wanted to make it a little bit interesting, I think instead of just walk, I can do some cum sum. It does not have this one because, okay, then I need to make it a numpy array. So W is NP array dot walk. That's W. Okay, to make it a better one, if a is equal to 0, then I'm gonna make it a -1. You see, this is a random walk, but it does not start from 0. So how can I make it always start from zeros? Is I just put the 0 here, and then it always starts from 0. And then every time I toss a coin, and when the coin shows a head, it goes up. And then next time it shows me a tail, it goes down. And this is the accumulation of all the coin tossing. And if I run it again, it will shows me another movement of the coin tossing. So this is the picture of a random walk. And you're going to learn a lot of the random walk when you are going higher and higher. But here I just wanted to express some, explain some of the details of this one. So why do we have a walk is equal to 0? Means I want to start from 0. So if I skip this 0 here, if there is nothing, then the walk list starts from an empty list. And then every time the random number is generated, the number will be added to this walk list. And this random number is basically a number from 0 and 1. So I want to make it to 0 and negative, I mean 1 and -1. So I add just one simple if statement. So if a is equal to 0, then I want to call it a -1, not 0, and then add it to the walk. So and I want to do that 100 times here. So first, so you may see, if I print the walk here inside the for loop, you will see a lot of print statement. So this is the result. The first one is 1, and the second one, 1 plus 1, and 1 plus 1 plus 1, 1, 1, 1, -1. So this is the growth of this walk list. We start from an empty list, and then it puts a coin, and then every time it records its coin result to 100 times, and then so this print statement is this one. And if I start from 0 here, then the first number is gonna be 0. So, and you can see there is no 0 here because all these are generated random numbers, and that generated random numbers, if that one is 1, it is still 1. But if the generated number random number is 0, then due to this if statement, it changes to -1. But I start from the 0. So let me run it. And then you see it's, because the first print statement is the result of the first coin tossing. It's 0, 1, and 0, 1, -1, and so on. And I make this one as a cumulative one. So if I don't use the cum sum here, if I just use the W here, I'm gonna erase this print statement, make it a comment. because I don't need to see that. Then this is just I start 0 and the -1, +1, -1, +1. It goes up and down, and then means we are recording coin tossing. But what I wanted to show you is the cumulative sum of this coin tossing. So in order to do that, I need to make it a NumPy array. So I make a new variable, W. So walk is a list, but W is a NumPy array. And since this is the NumPy array, I can apply various methods which are only available in the NumPy array. And one of them is cum sum. And it's a cumulative sum. So I'm going to plot the cumulative sum here, and it shows me this nice picture. And actually, this is the basis for the stock price movements. Okay. So if you want to do it by yourself, I'm going to, maybe I can copy you in a chat to everybody. Should be. Just copy from the chat and then put it in the Colab. Or if you are using the data camp, you can copy this one into the data camp also. Because in this IPython shell, it can take anything and then run it. Oh, MP is not defined. Okay, I'm going to import the NumPy first. NumPy as NP, and then in order to use the matplotlib, I need to import matplotlib.py plot as plt, and then I want to run it. I import NumPy, but I call it as NumPy. So I'm going to call it as NP. As NP. Import NumPy as NP. Okay. I can see the plot here. So what do you think about my explanations? Is it too hard, or is it too easy, or how about the speed? Am I too slow or too fast, or just right? So why don't you tell me your opinions?